I'm going to start talking about energy storage element, and primarily we have two kinds of energy storage element for electricity. The first kind is a capacitor, and right here I have a capacitor that can be charged to 2.5 volt for a storage capacity of 1000 farad, and that's a very big capacitor. It's also called a supercapacitor for its super ability to store electric charges. Now, on the other hand, I have this inductor, which is basically coils of wires, and about 100 turns of wire, and at either end, the leads of the wire are used to charge the inductor. And we will see the mathematics later about how a capacitor or an inductor can be charged. So let's have a look at what we're going to learn. Just a little bit of a review. So far we've talked about two kinds of circuit element. One kind are the sources. They can be independent or they can be dependent. Independent are things like batteries. Dependent sources are things like amplifier, and they can provide power to the circuit. And then the other kind of elements are the resistors, which are passive. They can only dissipate power and not provide power. Energy storage elements is fun. You can have capacitor that store energy in an electric field. Or you can have an inductor that store energy in a magnetic field. Capacitor inductors are passive element because they can only store energy. They cannot really generate energy like an amplifier can. Now, voltages and currents in a circuit without energy storage element are linear combination of source voltages and currents. If you have a circuit with energy storage element, then what you have is then the solution of current or voltages are solutions to linear constant coefficient differential equations, a lot more difficult than the case when you only have voltages and resistors. Even more fun is that you would need to go to Laplace domain analysis, and you can either use Laplace transform or a technique that we will teach in the future called AC steady state analysis. This technique would need you to learn a lot more about differential equation, and you can use Laplace transform technique to turn the solution of differential equation into algebraic problem that can be solved using the usual kind of algebra techniques. We learn about energy storage element because that's how you can store energy. And in fact, capacitors are almost ubiquitous in your computer and other electronics that you buy every day. An inductor could be a motor itself. So you also have a lot of capacitors and inductors that you can use to build filters and amplifier with the desired frequency responses. For example, you may have a radio receiver using what is known as a super heterodyne receiver, and you may have a radio frequency or intermediate frequency amplifier that use capacitor and or inductors to give you a filtering function. On the other hand, you can also use capacitor and inductor to provide instrumentation amplifiers so that you can boost the strength of the signal. So signal processing instrumentation also use a lot of capacitor for converting an analog signal into a digital signal by holding a sample signal in a capacitor until it can be converted into bits. In solid state, we also have integrated circuits that have layers of conductors with insulators such as glass in between the conductors. That effectively is an amplifier, and that amplifier is basically a capacitor. So this capacitance is one of the limiting factors in processing speed. So for example, in a signal processing circuit, because of the capacitance of the amplifier, the capacitance limits the speed at which signal can propagate through the circuit. We can also use capacitor to create random access memory. So in electromagnetic, where you have inductors, high frequency signal, inductance and capacitance have more significant effect than resistance because they limit the speed at which you can send your signal.